We are learning about 2D geometric transformation, where basically we are learning about translation, rotation and scaling. What is translation? We can move the object from one location to other. What is rotation? We can change the orientation of the object, which was something like this, and if rotated it can become like this. Okay, but it will remain on the same location. Other than that, there is something called resizing. You can resize it. We call it scaling. Okay, either you can increase the size or decrease the size. Let us start with understanding of translation. So what are we going to do in translation? Okay. We have just to add, suppose this is your pixel and you want to move it here. This means this pixel has a coordinate value. Okay, let me consider it as x1, y1, and you want the new position as this, which is whatever x2 I should call it, x1 dash y1 dash. Okay, new position. What are you going to do? Very simple it is. What is this x1 dash? X1 dash is nothing but x1 plus something. Okay, let me call it as tx. Okay, what will be the y1 dash? This is this position. This much y has been shifted. Let me call it ty. Okay, it will be the original y1 plus ty. So it is very simple to understand. Okay, what you did, you have to move a point from one location to other. That means you will add something to x and something to y so that it could be moved to that particular location. That's it. Now if you are moving an object, what does it mean? If you are moving an object to a particular location, it means you are adding this whatever tx and ty you have decided. You are adding this tx and ty to each and every pixel of this object. Okay, so it will be moved to a new location. Okay, however, while doing this, its size will remain same. It will not change. Okay, nothing will change, neither its orientation nor its size will change. What will change? Just its position. Sometimes you would have heard that what we do, we have an object here, so we bring it back to 0, 0, and then we perform certain operation and we transform it back to the normal place. You would have come across this. We came across this while writing program for circles. What we did, we had the circle, this point somewhere, center point, we brought it back to the center 0, 0, and using the radius we started to make the circle here, and once we have this circle here, what we did, in each of the pixel we add a particular tx and ty so that this circle is translated to its original center position, whatever its center position was. Okay. However, the size will not change. In my drawing, it may look like the size has changed, but size should not change. So this is something about your translation. Let me show this thing in a matrix form. What have we written here? This is your original point x1 y1. Let me call it as P and it as P dash. Okay. So how can I write it? P can be written as x1 y1 and P dash can be written as, suppose, x1 dash and y1 dash. Okay. So there is something called translation matrix T, which is Tx and Ty. Okay. So using this, you are getting your P dash. Okay. So initially you were having P, which was having x1 y1, and here you added this T to this P to get P dash. Very simple to understand. Okay. So do you have any question till now? So what is rigid body transformation? This is a kind of transformation in which the object moves. Okay. However, there is no deformation. Deformation means neither its orientation nor its size changes. Okay. So the orientation and size doesn't change, only the object moves. Such kind of transformation is called rigid body transformation, and translation is a rigid body transformation. Okay. Okay. Having talked about this, I believe now we can talk something about rotation. Now, what would happen in rotation? We are talking these things in 2D plane. So this is our 2D plane. Now what happens in this 2D plane? This is also a kind of transformation where your object is repositioned. Okay. But it is repositioned in a circular path. Okay. What happens?
Excuse me, sir.
Yes.
Excuse me.
Yes. What do you need in this rotation? You will need a pivot point. Okay. That means a point, let me call it a pivot point. Sometimes you may also call it pivot point. Sometimes you may also call it as rotation point. So whatever new point that you are going to rotate, this will be rotated according to this pivot point. Okay. So this your point, suppose this is P, which is to be rotated. This is your x axis, this is your y axis. If this pivot would have been at 0 0, in that case from 0 0 according to the x axis it would have rotated. But now we have to understand that whenever there is a rotation going to take place, it has a pivot point. Many a times it can be the origin, however many a times it may not be the origin, it can be a different point. So this is your pivot point, okay, or rotation point. From here you are going to rotate. Let me call this point as XR, YR. Now from this point, this is the straight line here. Now you want to perform some rotation. Whenever you will perform a rotation, there will be an angle. Okay. Let me call it as theta. And then you will get a new position for this P. You may call it as P dash. Okay. Now this theta is going in this direction, which means it is positive. This direction means counterclockwise direction. So this is a positive value of your theta. If sometimes the angle may go in a clockwise direction, it will be negative value for your theta. So whenever you will have positive value for this theta, you can understand that the object will be rotated in a counterclockwise direction. And if the value of theta is negative, in that case this object will be rotated in a clockwise direction. Very simple to understand. Okay. Now let us see some more things. What do we have to understand? We have actually understood that the object can be rotated, but we have to understand this thing mathematically. Okay, we have to derive some equations so that it could be used at the time of rotation. Okay. Now this is your P dash. Suppose it was what it was, your location x and y, x1 y1, okay, x1 y1, no issues. This is x1 dash, y1 dash. Okay. Now what can you do? Let us try to understand this. Basically, whenever this pivot point is something, can we translate these two to bring the pivot point to the origin? We will keep it here, and from here we can rotate it. Okay, and after rotation we can again translate these 2 points to the original position. It will be little helpful. Later on you can also learn to translate it from here itself. That is not an issue. Okay. So let me show you something. Suppose this is your origin. There was a point with coordinate xy and it has a angle, suppose phi. Okay, if it is on x axis, then it may be 0 degree, let it be, but suppose it also has some angle. Now this is the distance, let the distance be r. Now you want to rotate it, right? So rotating this with an angle, and this angle, let us suppose this angle is theta. Okay, you can understand that this distance r will remain the same distance r, right? This was xy and this may be your x dash y dash. Okay, these are the position. So now if we understand the trigonometric equations, we may say this something like this about x dash and y dash. What will be x dash? It will be r cos this angle. Angle is theta plus phi, right? Okay. So it can also be written as what happens to this? Cos phi plus theta. It will be r cos phi cos theta minus r sin phi sin theta. Very simple. This is about your r. R is already there. What is this cos phi plus theta? This thing. So r multiplied by this thing, and this is what you have got. Cos phi plus cos theta minus sin phi sin theta. Similarly, you can also write about the y value. Okay. What will be about the y? Y dash will be r sin phi plus theta. Is it? So it can be written as, what is sin a plus b? Anybody of you, do you remember?
Yes, sir.
Sin a plus b?
Sin phi cos phi plus
Okay.
sin phi sin theta. No, sir. Sin theta cos phi plus sin phi cos theta.
Sin theta cos phi plus
sin phi
I am multiplying r also. Okay, r
sin phi cos theta.
sin phi cos theta. Yes. So simple. So these are the two things. You can easily, if you know this xy position, you have this length r, and you know the angle, this angle and this angle, then you can easily determine the new position of x and y, okay, using this equation. Okay. This position, this is x and y. What was this position? This is r, and this position will be r. X will be r cos phi and y will be
R sin phi.
yes. So x and y, these can be represented like this: r cos phi, r sin phi. Now what happens? You have this r sin theta, sorry, phi, and r cos phi. Here also you have r cos phi, you have r sin phi, okay, r sin phi as well as r cos phi. Can this be replaced by these x and y? If I replace these, do you have any problem? Let me repeat it. We have just derived the formula for equation, I should say, for x dash and y dash. In this equation, we have found we have r cos theta r cos phi cos theta minus r sin phi sin theta, and for y dash we have r sin theta cos phi r sin phi cos theta. We have also understood that x can be written as r cos phi and y can be written as r sin phi. Having this information, can we replace this information in these equations?
Yes, sir.
So what will happen if we do this? Our x dash will be r cos theta is being r cos phi is being replaced by x, right? So it is x cos theta minus y sin theta. Similarly, y dash will be x r sin theta. This is y. R cos phi will be considered as x. So it is x sin theta plus this is y cos theta. Okay. So in a way what you have got is you can use this information of having the value x and y. So in your initial position there is p, right? P will be having what it has, x and y, right? You also have the information of your radius r, right? So in a way you can understand that your new position P dash is, okay, we are not talking about r, we will keep this thing in a separate matrix, cos theta sin theta, these things, and we will call it as r into your pixel matrix. So let me take it like this. Your R matrix is something like cos theta and sin theta minus sin theta. Okay. So In diagonally opposite side you have cos theta and sin theta. Only at one position sin theta is negative. So you have this r here. What was your p? P was your x as well as y. You can easily get p dash by multiplying these two matrices. Okay. Okay. Now, is there something else that you have any confusion? What we are doing here is, we have just verified that if we keep xy like this, perform the matrix multiplication, we will get the exact result what we expect. We have taken this example here, theta is 30 degree, p is 10, 12. What we have done, r we have considered, we have got this matrix. If we multiply this matrix with our given thing 10 and 12, what is it what we are getting here? We will multiply this thing, right? 10 root 3 by 2 minus, shall we write the result directly? 10 into root 3 by 2. Can I write 5 root 3? Minus,
Yes, sir.
minus 12 by 2. Is it 6? And here we can write 10 by 2, which means 5 plus 12 root 3 by 2, that is 6 root 3 by 2. Okay. So this is your new coordinate for x dash and y dash.
Sir,
It is 6 root 3 only, sir.
Oh, sorry, yeah. 6 root 3 only. Okay. You can also find further what is the value for this. No issues. Okay. Root 3 will be something like 1.7. What it will be? Root 3. Do you remember the value for root 3?
1.732.
1.732. So you will multiply it with 5, whatever it gets, you will subtract this value, get some value. So whatever the values are here, that are the coordinate for x dash and y dash. Now you will have to understand that coordinates, whenever you will get it, you will have to consider the rounded value, means some integer, right? Whatever value you are getting here, you will have to consider the integer. Now let us talk this thing that we have considered here. Let me remind you, this was your xy, right? Here you can see you have kept it as a column vector. Sometimes the question might be given to you like p is xy, like 10, 12. Okay. If such question is given, you either you have to transpose it to make it vector, what should I say, column vector, or you will have to transpose the both side, this also. Suppose, okay, if p is something like this, then what will be your p dash? P dash, you want the result in row vector only, so it should be calculated as transpose. Okay, it is R dot P matrices transpose. What it will be? If you perform this kind of transpose, it will be P
P
transpose
transpose R transpose.
R transpose. Okay. So such things can also be used as and according to the need. In that case, you have seen that the R will also be transposed. If R will be transposed, what will happen? In your R, this was the position where the sign was minus. If it will be transposed, that then this position sign will be minus, right? That is the only thing. In that case, what will happen? P, suppose if P comes in front, it will be X, Y. Will we be able to multiply this? Let me try. This is cos theta minus sin theta and sin theta cos theta. We cannot multiply this.
Hello, sir.
No, sir.
It will be row, sir. X and Y will be row.
So you didn't take transpose of P.
Yes, sir. Y should be in the row form.
Yeah, it should be in row form, but how?
Yes.
है ना?
No, sir. Yes, sir. It's a
Sir,
transport will
because
be.
you are taking a transpose of P.
Yes, sir.
See,
Here we are not taking transport.
Sir, above we have taken value of P as 10, 2 in the form of row, only row, 1 cross 2.
maybe you would be understanding. However, I believe I am getting confused or what. If it is a row, it is 10, 12. So what is happening? What we have discussed here is we have whenever we have to represent the output pixel in a row vector, what we do, we consider this pixel definitely in as the column vector, and then we perform this thing, a transposition. This transposition brings it in the front in a row vector kind of thing. Then we multiply it and we get the result as a row vector. Okay. So these two multiplication we get here, and these two multiplication we get here. Okay. So this is about your rotation. Okay. I believe now there is something called scaling. We can see the scaling maybe in next time. Okay.